To see sound, first let's understand what is sound. When we play a sound on speakers, they go in and out. When the speaker moves out, it pushes the air around, and when it goes in, it pulls the air along. This push and pull creates one sound wave. The wave travels around, and when it reaches our ears, we hear the sound. Let us say the number of times the speaker moves in and out in 1 second is f. We can create different sounds by changing this f. Let's say when a speaker moves in and out 100 times per second, which means f is 100, we typically get deep sounds like drums or like clouds thundering. You may have heard a mosquito. To produce a mosquito sound, the speaker would have to move at 17,000 times per second. Isn't that amazing? This means f is 17,000. This f is called frequency and its unit is hertz and denoted by its z. So we can say that mosquito sound has frequency of about 17,000 hertz. Coming back to how do we see sound, this is our setup, a string connected to a plastic cap which in turn is connected to the speaker. Our setup can only respond to sound frequencies below 60 Hz. When speaker moves out, it pushes the string, and when it moves in, it pulls the string. This portion we see is on account of push and this is on account of the pull. Both of them together form a wave. Since the string is tied at the far end, the wave cannot move forward and we get patterns like this, which we call a standing wave. Notice that this point remains stationary. We call it a node and we'll show it by a purple arrow. The string moves around this node as a wave. Now let's see it with a song. As the sound frequencies move higher, our setup stops working, but we see some interesting patterns. This is one wave, so this distance is a wavelength. We observe that as frequencies go higher, the wavelength becomes shorter.